Hello, welcome to PDA class. So today I'm going to show you how to solve the PDA question. Okay, let's flashback a little bit what you have learned before. Okay, we have learned this example 2 and then definition, any PDA, all the classification, some important PDE, all these three PDE equations. Right now we go to the method of solving boundary value problem. Right, so there is a two method, which is SOV, expression of variables, and numerical, but the one numerical we're not going to cover in this class. Alright, for SOV, first we assume solution can be expressed as above and then apply the assumption and then to determine the solution, and then the last one is use various to separate inputs. Right, I'm gonna show you the simple example first. We start with example 4, which is not a head or wave equation, it's just a straightforward. Okay, we're going to solve this by using the method of solving. Right. Okay, so I'm gonna start show you how. Okay, so we have the assumption. So from the beginning we have to assume the solution is in terms of u equals to x times y. Okay, so after that, first method, the first step that you should do is to differentiate, similar to the question on the questions. Okay, so you're going to differentiate with respect to x and with respect to y. Okay, once we did that, okay, we're going to replace it back into the original equation. Okay, which you already seen in the example for earlier. So x prime y equals to 4xy prime. Okay, now we're going to apply the SOV method, which we're going to separate x with x and y with y. Okay, so x prime divided by x is equals to 4 y prime divided by y. Actually the 4 you can take it anywhere, but please stick with 4 on the y side, and then equals to negative lambda. Okay, now we're going to separate it, so x with x and y with y. Okay, separate it accordingly. Okay, now we're going to focus with x first. Okay, if you still remember the auxiliary form that you learned from second ODE, so we're going to use that. So we reduce it into auxiliary form. It becomes m plus lambda equals to 0 and m is negative lambda. So that is our roots. Okay, then our solution is x equals to e exponent negative lambda x. Okay, we're done for x. Now we go to y part, same. So 4y prime plus lambda y equals to 0, m 4m plus lambda equals to 0. Then we will obtain m is equals to negative lambda over 4. Okay, then we will got the solution for y is b exponent negative lambda over 4. Right now we have both solutions for x and y. We're going to replace it back, okay, into the assumption. Our first one, not that one. Okay, the first one. Okay, that one u equals to xy. Okay, yeah, that one. Alright, so u equals to a exponent negative lambda x times b exponent negative lambda over 4y. Okay, now we're going to combine it. So constant times constant, it become another constant. Okay, remember that. So exponent, we also combine it. We put the negative outside. That's all. Okay, the rest is as usual. Still have x and y there. Okay, then finally, the last step for this simple method, we apply the boundary condition. Okay, so no further yet, that one will be saved for head letter. Okay, so there is only one boundary condition, which is u0y equals to 8 exponent negative 3y. Okay, so you're going to replace it. Okay, that means let's say 0, y is still there, and equals to 8 exponent negative 3y. So we do a direct comparison. Okay, lambda n the constant, so definitely c is equal to 8, and negative lambda over 4 is equals to negative 3. That means lambda is 12. Okay, by replace all those two constants that we got by comparison, hence we got the final solution, which is uxy equals to 8 exponent negative 12x plus 3y. That's all.